Okay, so we're now talking about some serious stuff, product and quotient rules. And I'm not going to just jump ahead to examples like I sometimes do, because I feel very deeply that you need to see this a couple different ways. This is a rule that a lot of students struggle with intellectually. It's not hard to compute these things. I mean, it's annoying, but it's not difficult. The hard part is actually believing that it's true and understanding in your gut why this is the way the world is. And so I'm going to take a couple different approaches to convince you that this makes sense. And then at the end of the video are the examples. So if you're already convinced, for example, if you took calculus before and you're already convinced that this is true, you can forward ahead in the video to the examples, and that's fine. But if this is your first time hearing about product and quotient rules, please listen to at least a couple of the explanations so that you can internalize what it is that's going on here. But even though I said I wouldn't start with examples, I will start with one little example to try to motivate. Okay, so if you have a function, and I'm going to make it very, very simple so that we can tear it apart. We have something like 2x plus 3 times 4x minus 1. And we could just use what I'm going to show you, the product rule, or we could multiply out and then take the derivative. So I'm going to do it two different ways. I'm going to multiply. F is actually, let's FOIL this, first, outer, inner, and last. So what's 12 minus 2 is 10. So it's 10x in here and minus 3. Okay, so that's what the function really is. And so the derivative, of course, of this function has to be 16x plus 10. So we know that that is the derivative of that function. But let's pretend that we don't have the option of multiplying the pieces together. We have this function, which is, let's say, function a of x, and this function, which is function b of x. What the product rule tells us is to take the derivative of f, we have to do the first thing times the derivative of the second, plus the second times the derivative of the first. Now, students often mistakenly think that they would rather just take the derivative of the first times the derivative of the second. And let's just first demonstrate why this doesn't work. A prime is just 2. And b prime is just 4. And if you multiply those two pieces together, you would simply get 2 times 4 is 8, which isn't even part of this discussion. It doesn't even happen ever. So what happens if instead you follow the right strategy? Let's say 2x plus 3, that's the first, times the derivative of the second, plus the second times the derivative of the first. Does this at least work? 8x plus 12 plus 8x minus 2, and guess what? We actually got the correct answer. So at least one example, hopefully you can see, okay, there may be something to this crazy looking rule. Okay, so that's the first attempt to convince you of this. Second attempt, I want to give you a word problem. I want you to understand this from a word problem perspective. Having trouble with my pen, like always. Let's say you're a store and you're selling some items. Okay, I'm going to draw this picture. In this place, you're going to get a little bit of credence given to your instinct, perhaps, to multiply the two derivatives together. But I want you to think of this. Let's say that this represents that I'm selling 100 barrels of something, anything. And here's the price at which I'm selling them. I'm selling them at $55 each. So then the amount of money I get is $55.00. That's the total amount of money I'm getting for selling 100 barrels for $55 each. Maybe that's one day. One day I do that. Then the next day, everybody hears about my great low prices, and I sell more, but I can increase the price because now people know I'm here. I'm gonna increase this by $5 more, but I'm also gonna get 10 customers more, okay? So what's the difference in the amount of money I make? Well, this right here is the extra money I get if I kept the price the same, but I just had extra customers. I would get $550 more. Well, what about if I instead kept the number of barrels the same, my sales is the same, but I just increased the price, then that would give me $500 more. Okay? This little piece over in the corner here is the extra piece, is the extra money paid by the extra customers. This is equivalent to multiplying the two derivatives together. And in reality, as you squeeze these things down closer and closer to zero, these pieces, the pieces that are pink or purple, those count way more than this tiny little piece, which is 10 times 5, which is just 50. And in the context of these thousands of dollars, this $50 doesn't really mean much. That's just the extra money that the extra customers paid because they were new customers and they paid the new price, right? But what's way more important is how much extra money came in simply because we had more customers, plus how much extra money came in simply because we increased the price. And those two effects are kind of thought of separately and they work together. Okay? I'm going to give you a couple more ways of looking at this. Okay, so I want to use the definition of the derivative in one of my explanations. All right, so if I have a function which is, let's say, f, and a different function over here that's g. Okay, I like to have pictures. This is going to be mostly algebra, but I want you to get a picture in your mind. You have two functions, and we're going to evaluate each of them at x and multiply them together. I want to find the derivative of the whole thing, and I have at my disposal f and f prime, whatever f prime is, and g prime. That's what I have to deal with, but I want to investigate what happens when I multiply f and g together. Okay then, well, I'm going to give it a new name. Q of x is equal to f of x times g of x. So what is q prime? Is the limit as h goes to 0, q of x plus h minus q of x. Well, what is that? Well, is f of x plus h times g of x plus h minus f of x g of x over h. Pretty straightforward, right? But hold on a second. Didn't we do something already where we said limit f prime of x is limit as h goes to 0 of f of x plus h minus f of x all over h. Didn't we say that? Well, what if I just temporarily ignore this limit symbol? Because I'm not going to go to 0 quite yet, but I'm going to just say the following. When h is very small, this is close to being true. And let's say maybe I might need this sometime. I might want to say f of x plus h times f prime of x is approximately equal to f of x plus h. And that really makes sense because we're talking about the tangent line here. We're talking about here's our f, here's our x, here's our h. And so we're saying if we had this tangent line, we could make a little step here, and we would get to f of x plus h over here, f of x plus h. We would arrive there by stepping out from f of x in the direction of that slope by a step scaled by h. And that would get us to this destination. So if we believe this is approximately true, and I'm going to throw this back inside the limit anyway, so who cares, and this is going to be the same for g of x, I can replace f of x plus h with f of x plus h f prime of x, and I can replace g of x this way. Let me see what happens if I put that back in the formula. Okay, so f of x plus h was f of x plus h times f prime of x, and g of x is g of x plus h is g of x plus h times g prime of x. Thank goodness we're going to subtract that f of x and g of x because we've got way too many terms as it is. I'm not really sure what we're going to do with them. Actually, I am sure. That's okay. But we're going to FOIL, and then that first term, I'm going to drop all those letter x's because they're just really annoying. I'm just going to write it this way. Okay, so I have f times g plus h f prime g plus h f g prime plus h squared f prime g prime minus f g over h, and these guys cancel out. And then, as we always have in these lovely problems, we have a surplus of h's so that everything on the top gets at least one extra h to get rid of. This final term that everybody wants to use just goes away because in this case we don't need it. You will need it in higher level math, but you don't need it for this. That term where f prime times g prime is still multiplied by a single h, and so when you're done, you just have f prime g plus f g prime. Those are the only pieces that remain. So that f prime g prime is not a figment of your imagination. It's just very, very tiny, and when h goes to 0, it goes boop out of existence. Okay? This is not the most important thing. The most important thing are these guys. They stick around for the long haul. Okay, now for the examples. Okay, I'm going to make sure to go over at least one of each kind of example of the things you'll be asked to do in the worksheet. And the first is just the standard question. You'll have questions there. You have things that are obviously grouped in, two separate multiplied functions. And usually we try to do something that, if one's a polynomial, the other one probably won't be a polynomial, just so that you don't try to multiply through. Because normally, like if you had two polynomials, you should just multiply them together. So if we want to take the derivative of something like this, you just say, okay, the first and the second, so you need p q prime plus q p prime. All right, so we go ahead and figure this out. So you're going to have the first times the derivative of the second plus the second times the derivative of the first. So make yourself a little placeholder so that you can get everything ready. Okay, so that's p times q prime. And what is q prime? Well, it's one of those e to the x type functions, but it kicks out a natural log of 3 because it's not e to the x, it's something else to the x. So there, we got to do that. Okay, now what about this other one? Well, the derivative of x squared minus 3x is just 2x minus 3. And in the case of your homework, I'm going to ask you, or sorry, the worksheet, I'm going to ask you to evaluate at a specific point. So let's say I might ask you f prime at 1, and then in that case you're just going to do some kind of quick figure out what this is, any 3 to the 1 is just 3, so you're going to get another 3 in here. And then 3 to the 1 is 3, and then it would be 2 minus 3 is negative 1, etc. Okay, so just be prepared to evaluate that derivative somewhere so that you have something cool to key in as something to do on your worksheet. Let me talk about the quotient rule next so that I can sort of do these in parallel. But if you want to know why the quotient rule works, you could just rederive it from the product rule, and so I'm going to do that. So I'm going to just do a little bit of theory here. What if the thing we want to determine the derivative of is p of x over q of x? Okay? And we want to take the derivative of that. Well, that's the same thing as saying p of x times q of x to the negative 1. Okay, so in other words, I want you to think of this as q of x to the negative 1. Okay, so here's the thing. We have not done the chain rule yet, so you will need the chain rule to derive this. So I think after I get to the chain rule, then I'll come back and do this little proof for you. Okay, so let's figure out what that equals. That equals the square of the bottom, and then it's the bottom times the derivative of the top minus the top times the derivative of the bottom. So what people sometimes say is low-de high minus high-de low, and it's just a very silly thing people say. They say it because it sounds funny and it helps them remember. It sounds almost like some country bumpkin speaking, like high-de low, low-de high, something like that. I don't know. It just sounds very silly. And so they say low-de high minus high-de low, and there you go. Maybe that's a good memories trick for you. Okay, so back to the examples. What if you have f of x is equal to, let me try something like x squared. Well, it would help if my pen were working. Oh, it would help if my whole computer weren't broken. Okay, sorry about that, guys. Sometimes my computer just behaves strangely and I can't explain it. Alright, so let's say we have some kind of denominator and we have some kind of different numerator, and we want to take the derivative of this. So we take the denominator and square it. Square it. And so you kind of think in terms of making a template up here. And then put all the stuff in here that you need. So the bottom times the derivative of the top minus the top times the derivative of the bottom. Now let's go take some derivatives. So it was the bottom times the derivative of the top minus the top times the derivative of the bottom. Well, since e to the x is its own derivative, this thing looks kind of weird. You can regroup and put e to the x together, but I'll let you do the algebra yourself after you've done that first step. Okay, so there's an example with the quotient rule. All right, next kind of example you might be asked to do. Instead of being given an actual function, you're just given a theoretical function. And we just give you a couple pieces of information. And then we say, find the derivative of f times g at x equals 3. And you're like, what? We don't know what the function is. Well, we know it's f times g prime plus g times f prime. All of those things evaluated at 3. F of 3 is 7. G prime of 3 is 2. g of 3 is 4, and f prime of 3 is -1. So 14 minus 4 is 10. At least I think it is. All right, so that's what we get for that. And there's also, let's see, you could do a quotient rule, or you could just add. You could we could have questions like, with the same stem, you could have questions like f plus g, take the derivative of that. Okay, in that case it's f prime of 3 plus g prime of 3, and that's just going to be 2 minus 1, which is 1. Now, there's also another tricky one, and it looks like this. It looks like f times g squared. And the way I'm going to ask you to do this, since we don't have the chain rule yet, I want you to treat it like f times g. We want to find its derivative. And so what you want to do is first group off this g times g and say, hey, wait, I need to know what the derivative of g times g looks like. Well, it's the first times the derivative of the second plus the second times the derivative of the first. So it's just 2g prime. And in that case, we have the g and the g prime. So it's just going to be 2. So it's all at 3. G of 3 is 4. G prime of 3 is 2. So that's going to be 16, right? So we have that piece figured out. So now we also have to know what is g times g without priming, and then that's just going to be 4 times 4, which is, ironically, it's also 16. It just doesn't, it's coincidental. All right? So then the way we're going to pull this thing apart is we're going to say, all right, this is the first block and this is the second block. So I want f times the derivative of gg plus gg times the derivative of f. I'm going to put all that back together. What is f at 3? Is 7. Gg prime at 3 is 16. Regular gg happens to also be 16. And I forgot to put the prime on that guy. F prime at 3 is -1. So then that's going to be -1. So it's 7 times 16 minus 16. So whatever 6 times 16 is, I don't feel like calculating that right now. Oh, I guess it's like 60 plus 36. So that's actually 96. Okay. So that's how you would do that exercise. If you happen to already know the chain rule, you can go ahead and use it, but it has not been introduced yet. So I just wanted to give you an alternate way to do that exercise since it's on your worksheet. Okay, so the next kind of question you need to know how to deal with is, what if you have these crazy graphs? Okay, so in these questions, I want you to think of this type of question where I'm asking you like derivatives, quotient rules, all this crazy stuff. I'm sorry, product rule, quotient rules. I want you to think of it just like the problem we just did, except that you have to pull this information off of a graph. So let me just make one up, I guess. So if I tell you I want you to find the derivative of f times g at, let's say, x equals 2, then what I need to do is I need to find g at x equals 2 and f at x equals 2. In fact, I'm just assuming one box is 1 unit. I need to find the derivative at each point. So I just say, okay, f at 2 is equal to 1. F prime at 2 ironically also equals 1. G at 2 equals 1. I'm very sorry. And then g prime at 2 is not 1. It's actually, what is it? Rise is 1 over run is 2, so it's 1/2. Okay? But then I assemble all these pieces the same way I did in the last exercise. It's the first times the derivative of the second plus the second times the derivative of the first. Okay? But let me pick another one out of this same chart, the same graphic. Instead of x equals 2, let's make it x equals -3. So -3, well, the limit doesn't exist. I'm done with that one. Okay, so let's not do that one. But if it doesn't exist, you write dne. So -3, it would be dne. But we're going to do -2 instead. Okay? Let's get rid of these other ones. Okay, -2. -2. Now this is kind of nasty because this is a 3 against 5 situation. Your slope here is 3 against 5, so the slope isn't bad, but I'm having a hard time estimating that point. So in your exercises, very rarely will I ask you to guess something like that, but I just kind of threw this thing together on the screen. So what is that actually? Let me figure that out. Okay, so sometimes you have to pull out the heavy artillery, and that little thing is, that little line segment will intersect the y-axis at 5, and it has a slope of 5/3. So I said, let me just go ahead and write that for a second. So y of -2 is going to be 5/3. And the rest of these we should be able to figure out without using fancy tools. Okay, f at -2 and f prime at -2 we need, and we need g of -2 and g prime of -2. So we got to figure out all these things before we can go to the next stage and actually solve the problem. So f at -2 is 5/3. F prime at -2 is, well, 5/3. G at -2 is 2. And g prime at -2 is -1. Well, so two of my numbers match, so I'm sorry about that. But at least it's not all ones this time. So anyway, it's going to be the first times the derivative of the second plus the second times the derivative of the first. So it's going to be a total of 5/3, big shock. So f g prime plus gf prime is 5/3 times -1, so that's -5/3. And then it's going to be 5/3 plus times 2, so it's 10/3. So all total we end up with 5/3. So hopefully those two examples are enough to show you what's going on with that exercise. And the rest is just sort of advice for the questions. There's a question which I'm not going to give you the answer to, but I want you to think about. The question is, now that you know how the product rule works, if you saw something like this, if you saw this function, what would you think? What would you think that it was the derivative of something? So f prime is equal to this mess. Can you figure out what f it came from? And so that's a puzzle for you. And so on the worksheet, on the quiz, it's going to have, you know, boxes for you to fill in, and part of it I fill in, and part of it I'll say, hey, I'm going to give you a clue. There's a number here, but I want the exponent here. I want this value. I want this value. So that'll be a fun little exercise for you to do. And finally, the last exercise on your worksheet is one that I had never seen before, and I really love it. And I'm going to let you guys have fun with it, and I'm not going to spoil it for you. But use the product rule to find the derivative of this function. Do not expand it out. And then what's going to happen is the next exercise right after that, you're going to have to extend that. But what's happening is you've already done half the work at the previous stage. So you've already got the derivative of this mess. So this now becomes your first function. And then you do first times the derivative of the second plus second times the derivative of the first. And then you go on to the next stage, you take that into overtime, and you're just going to keep tacking more pieces on. And then you're going to say, okay, but if we already got the previous question, that previous question now becomes f for the new stage. So that's just a little bit of strategy advice on that. And hopefully, if you keep all your work straight and careful, you will be amused and pleasantly surprised by what happens, because maybe you didn't think about it before. But hopefully you'll enjoy that exercise. And I believe this is all you need. That's all you need for worksheet 15. See you soon.